Okay, so imagine this for a moment. For centuries, humanity has asked a question that feels almost forbidden. What existed before the Big Bang? At first, it sounds like something we were never meant to answer, like philosophy trying to disguise itself as science, like speculation filling the gaps where knowledge fails. But that assumption is wrong. Every idea you're about to hear was developed by physicists and mathematicians working at the highest level, published in peer-reviewed journals, actively debated in modern cosmology. This is what happens when science reaches the edge of reality, and instead of stopping, it keeps going. Because at that edge, the universe stops behaving the way we expect. Cause and effect begin to blur. Time loses its meaning, and before might not even be a valid concept anymore. Number 7. Conformal cyclic cosmology. When we think about the beginning of everything, we imagine a starting point, a first moment, a line drawn in time. But Roger Penrose proposed something far more unsettling. What if the beginning and the end are actually the same thing? In conformal cyclic cosmology, the universe doesn't exist once. It exists over and over again in an infinite sequence of cycles called eons. To understand what came before our Big Bang, you have to imagine the farthest possible future. Trillions upon trillions of years from now, every star will burn out. No new stars will form. Galaxies will drift so far apart that they disappear beyond each other's horizons. The universe will become almost completely dark. The only remaining structures will be supermassive black holes, quietly consuming the last traces of matter. But even those don't last forever. Through Hawking radiation, black holes slowly lose energy. In timescales so vast they're almost meaningless, they evaporate completely. Eventually, the universe is left with nothing but radiation, no mass, no structure, just photons moving endlessly through expanding space. And here's where reality becomes almost impossible to visualize. For a photon traveling at the speed of light, time doesn't pass. Distance doesn't exist. From its perspective, the entire lifetime of the universe is compressed into a single instant. That means an infinitely large, cold universe and an infinitely small, hot beginning become mathematically indistinguishable. The geometry of spacetime collapses into something new. The end of one universe smoothly transforms into the beginning of another. No reset, no external trigger, just a continuous loop. Penrose even suggested this might leave traces, patterns in the cosmic microwave background, faint circular imprints left behind by events in a previous eon. Some researchers claim they've seen them. If that's true, then the night sky isn't just showing us our past, it might be showing us the memory of another universe. Number 6. Quantum fluctuations from nothing. Our intuition tells us that something cannot come from nothing. But at the quantum level, that rule doesn't apply. In quantum mechanics, particles constantly appear and disappear. No warning, no cause, just probability. So what does nothing actually mean in physics? It doesn't mean emptiness. Even a perfect vacuum contains energy. Because of the Heisenberg uncertainty principle, energy can never be exactly zero. That means the vacuum is constantly fluctuating. Tiny particles emerge for a fraction of a second and then annihilate each other. This isn't theoretical. We've measured its effects in real experiments. Now imagine scaling that up. Instead of a particle, a universe. At first, it seems impossible, but gravity changes everything. Matter has positive energy. Gravity has negative energy. Add the two together, and the total is zero. which means the universe doesn't break any rules by existing. It can emerge spontaneously. A tiny fluctuation in a quantum vacuum could expand rapidly through inflation, stretching space faster than light and becoming everything we see today: galaxies, stars, planets, you. The implication is difficult to accept. There may have been no moment of creation, no purpose, no intention. Reality might simply be the result of a random fluctuation that didn't disappear in time. Number 5. Loop quantum cosmology. In standard cosmology, everything begins with a singularity, a point of infinite density where the laws of physics stop working. But infinities aren't physical. They're a sign that something is missing from the theory. This is where loop quantum gravity changes the picture. In this model, space itself is not continuous. It's made of tiny, discrete units, like pixels forming an image. There's a smallest possible size, a fundamental limit to compression. So if you rewind the universe, it doesn't collapse into infinity, it hits that limit. And when it does, gravity behaves in a completely different way. Instead of pulling inward, it becomes repulsive. The collapse stops and then reverses. The universe rebounds outward in a violent expansion. What we call the Big Bang was actually a bounce, the aftermath of a previous universe collapsing in on itself. That universe may have looked very similar to ours. It may have had galaxies, stars, possibly even life. All of it compressed into an unimaginable state and then released again. If this is true, then reality is not a beginning, it's a cycle, an endless chain of universes being born, collapsing, and being reborn again. Number 4. The Ekpyrotic Universe. To understand this model, you have to think beyond everything we can see. According to string theory, our universe may not be all of reality. It could be a three-dimensional surface floating inside a higher dimensional space. This surface is called a brane, and there may be others, parallel universes existing right next to ours, but completely invisible. Before the Big Bang, our universe may have been empty, cold, lifeless. Then something happened. It collided with another brane, a collision across higher dimensions. The energy released in that impact was enormous. It filled our universe with matter and radiation. It created the hot, dense state we identify as the Big Bang. But this wasn't a one-time event. After the collision, the branes separate. The universe expands and cools, but the attraction between them remains. Slowly, over unimaginable timescales, they move toward each other again, until eventually they collide once more. Each collision resets the universe. Each one creates a new beginning, which means the Big Bang may just be part of an ongoing cycle of cosmic impacts. Number 3. Eternal inflation. Inflation explains why the universe looks smooth and uniform. But when physicists like Alan Guth and Andre Linde studied it more deeply, they discovered something unsettling. Inflation doesn't stop everywhere. It keeps going, forever. Our universe is just one bubble inside a much larger system, a multiverse. In this model, space is constantly expanding at different rates in different regions. In some places, inflation stops, forming a universe like ours. In others, it continues indefinitely. New universes are constantly being created, each one potentially with different laws of physics, different constants, different possibilities. Some might collapse instantly, others might never form stars, and a few, like ours, allow complexity to emerge. We are trapped inside one of these bubbles, surrounded by others, but forever separated from them. Number 2, the CPT Symmetric Universe. The laws of physics rely on symmetry, charge, space, time. If you reverse all three, the equations still work. But our universe doesn't reflect that symmetry. We have matter, not antimatter. Time flows forward, not backward. So where is the missing half? One theory suggests something radical. The Big Bang didn't create one universe. It created two. Ours expanding forward in time, and a mirror universe made of antimatter moving backward. From our perspective, it exists before the Big Bang. From its perspective, we are the past. Two universes born from the same moment, moving in opposite directions through time, forever connected, but forever separated. Number 1. The string landscape. At the deepest level of physics lies string theory. It suggests that the fundamental nature of reality depends on the shape of hidden dimensions. But there isn't just one possible shape. There are around 10 to the 500 possibilities. Each one corresponds to a different universe, different laws, different physics, different realities. This is known as the string landscape, a vast mathematical space where universes are constantly being generated. Most of them are unstable, hostile, empty. We exist in one of the rare configurations where structure is possible, where stars can form, where chemistry works, where life can exist. Not because it was designed that way, but because if it weren't, we wouldn't be here to observe it. We are a statistical outcome, a tiny island of order in an infinite ocean of chaos. The most unsettling part isn't what existed before the Big Bang. It's realizing that the concept of before might not even apply. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.